Hello guys, we will be reacting to uh, Matthew Berman video for GPT 4.1. It's a very nice video, I love this guy.
GPT 4.1 was just announced and released. We have a brand new model. It is better in almost every single way to GPT 4.0, and it's significantly cheaper. And it is only available via the API, and there's a reason for that.
Now that's interesting. We don't have a comparison to other providers. That's saying something, I think.
Model was specifically tailored for developers to use. And GPT 4.5 is actually getting deprecated in favor of 4.1. More on that later. And so there's a bunch of exciting announcements.
As always, we have alienness in the versioning convention, but let's see.
Go over them all. I'm going to show you some demos and let's get into it. Here's the blog post introducing GPT 4.1 in the API. And I found it very interesting that it's literally only available in the API. Obviously, you can wrap it yourself and treat it as a chatbot, but it is not available in the ChatGPT interface, at least not yet. So GPT 4.1 is a family of 3 models. We have 4.1, 4.1 mini, and for the first time in OpenAI's history, 4.1 nano. Extremely fast.
That's interesting. Will this be the direction where OpenAI will start to dig in more than the competitors, making smaller models? I think it's a very nice direction.
Extremely inexpensive. And 1 million tokens of context. This is huge. One of the biggest drawbacks of OpenAI's model.
I generally think that the future of these models are not having one big model, which is a painkiller for everything. Obviously, that's a big challenge. Yet, smaller models, smaller and better small models. I'm really curious about this nano. Let's hear it.
Models has been their limited context window as compared to their frontier competitors. But now they have at least taken a big leap in the direction of large context, 1 million tokens. Now, these 4.1 models, as it says right here, outperform GPT 4.0 and 4.0 mini across the board with major gains in coding and instruction following. And it's not just that they gave them very large context windows, they're actually really good at utilizing those very large context windows, as I will show you. They also mentioned in this blog post they have a refresh knowledge cutoff of June 2024. And it's always interesting to see when those knowledge cutoffs are because it gives you a hint as to when the training basically ended. Let's take a look at some benchmarks. For coding, GPT 4.1 scores a 54.6.
I don't practically agree, technically agree that the end of learning is when the training. It's like
on the SWE bench verified, improving 21.4% over GPT 4.0 and 26.6% over GPT 4.5, which is crazy. And continues their absolutely horrific naming scheme. 4.1 is now better than 4.5. And I'm kind of sad what's going on with 4.5. But again, I'll talk more about that in a minute. It is.
Bro, this is strange. How can you release a 4.1 version when you have a port 4.5? I don't really. I'm sorry. I'll take a moment. I'll take 5 seconds for somebody to think of a reason. Please comment in the video if you use these 5 seconds to really find out the reason. 1, 2, 3, 4, 5.
Is, according to them, the leading model for coding. and they actually brought in a special guest during the live stream, Varun, the CEO of Windsurf, to talk about that, and I'll show that video in a little bit. Then on instruction following, Scale's multi-challenge benchmark, a measure of instruction following by ability, GPT 4.1 scores 38.3 and a 10.5% increase over GPT 4.0. And not only that, OpenAI is actually releasing their own instruction following benchmark, and I'll give you the scores on that as well. But first, long context. On Video MME, which is a benchmark for multimodal long context understanding, essentially loading up videos. And yes, this is a multimodal model. GPT 4.1 sets a new state-of-the-art result, scoring 72% on the long, no subtitles category, a 6.7% improvement over GPT 4.0. So this is, in fact, the natural success.
But what is the purpose of comparing to local comparison?
Of GPT 4.0. It wasn't GPT 4.5, and I have some thoughts about that. I've already mentioned that they're going to be deprecating GPT 4.5. And so why? What is actually happening? Well, according to Kevin Weil, the chief product officer of OpenAI, they simply need the GPUs. They have all of these GPUs that were required to power GPT 4.5, which is a massive model. It was slow. And now they need it for this API-based model that is much more, I think the best word is usable. And so soon, GPT 4.5 will be...
What? So, it's not like you have a GPU and you just brand it 4.5. Like, that's a resource which is routable, and these big companies I really doubt they don't have guys to do some routing code where to route the thing. I mean, it's not like this whole data center is only for 4.5 and this whole data center is only for that's not serious. I think they are not happy with the 4.5. That's why they
deprecated. And I don't actually think that's going to be forever. They have this incredible model, this large model, and I actually suspect it's a model that they're going to continue to build on. They're going to continue to fine tune. They're going to bring the prices down, make it more efficient. I just think they shipped it too early and it was too expensive and too slow. And there is a GPU shortage. Still, years into this generative AI boom, we still have GPU shortages, which is absolutely crazy to think about, because the amount of demand that these companies must be experiencing to have GPU shortages, even though so much money has gone into purchasing and producing GPUs, is just mind-blowing to think about. Now, back...
It's mind-blowing the need, how much GPU is needed. Because imagine today there are 10,000 developers which integrate AI into their workflow, like the whole day workflow, and that's a lot of GPUs. Let's say roughly you need 10,000 more GPUs today. I don't think there is a factory which is producing 10,000 GPUs at the moment on Earth, but daily.
Back to 4.
Or all of the factories. So of course, and it might happen every day. The community to have 10,000 more developers integrating the AI into their workflow.
4.1. What's interesting is they specifically say they trained this model to have real world utility, and they worked with the development community. They worked with Windsurf, obviously. I'm not sure if they worked with Cursor and Replit and other companies that also provide really cool vibe coding tools, but they definitely worked with the developer community to create the best possible models. First, let's talk about latency, the speed at which these models deliver results. Now, one of my pet peeves is graphs with no labels whatsoever, and that's essentially what we have here, but I'm still going to go over it briefly. On the y-axis, we have intelligence on the multilingual MMLU. On the x-axis, we have latency. We don't know what the latency...
This is a salesman graph. Just show it's better. Guys, believe me, it's better.
is because it's not labeled here, but fine. Relatively speaking, GPT 4.1 Nano has lower intelligence than the other models, but is also much faster. But they even said this in the live stream. GPT 4.1 Mini is the true standout of this family of models. Look at that. A huge improvement in intelligence versus GPT 4.0 Mini, yet the latency is about the same. And we have GPT 4.1 up here above GPT 4.0. So definitely higher intelligence, same latency. And listen to this, GPT 4.1 Mini is a significant leap in small model performance, even beating GPT 4.0 in many benchmarks. It matches or exceeds 4.0 in intelligence evals while reducing latency by nearly half and reducing cost by 83%.
Whoa. Reducing cost by 83%. I think that's what they're releasing. I don't think they're releasing something which is very smart. I think they're releasing the 83% cost reduction. No?
Now, the cost is especially important when you're talking about giving an API to a developer, because then you are not limited by how fast a human can type out a prompt and get the response. It is programmatic. And so the potential cost of using these models is much higher, exponentially higher. Now, the cool thing is every one of these models has a 1 million token context window. And speaking of price, they're not charging extra for that long context. A lot of their competitors, which they pointed out, will charge you extra to use that really long context, but that's not the case with GPT 4.1. You simply pay for the tokens you use consistently across the token context window. And so with long context, with multimodal understanding, with its incredible ability to read charts and understand documents, of course, the enterprise use case is going to benefit the most from this. And that's why I want to show you some of the benchmarks that Box, the sponsor of today's video, put together and some of the information that they were able to gather as an early partner on 4.1. So here's the blog post. I'll drop this down below. First look, GPT 4.1 now available with Box AI Studio. All right, so check out this benchmark. This is the Box AI Enterprise Eval. We have in purple GPT 4.1 versus GPT 4.0 in yellow. So this benchmark tests the model's ability to extract certain pieces of data from different types of documents. So on the left, we have secure data escrow. 4.1 nearly doubles at a perfect score. We have insurance documentation, a huge leap, warranty duration, liquidated damages, non-disparagement clauses. So the ability to extract the right thing from these complex documents, and a lot of documents all at once, really seems to be 4.1's best feature. All right, so let me show you that in action. Here's a demo. So we have NVIDIA's earnings. This is Box AI right here. We're going to ask it, please list the key trends from the earnings call. So key trends include record revenue growth. It gives you specific numbers. It gives you comparisons to previous quarters, previous years, data center dominance and Blackwell ramp, AI scaling laws and compute demand. So very successfully pulling information out of this complex document. Check out GPT 4.1, give it a try in Box AI Studio. They've been a fantastic partner, so please check them out. I'll drop a link to them in the description below. And if you want to try out 4.1, email them at ailabs@box.com. Thanks again to Box. So GPT 4.1 Nano, 1 million token context window, scores 80.1% on MMLU, 50.3% on GPT-QA, and 9.8% on Aider polyglot coding, even higher than GPT 4.0 Mini. So this is the nano version, the smaller version. It's ideal for tasks like classification or auto completion. This is the workhorse of this new 4.1 family of models. And
yeah. Classification, they said. I think this is the future. The classification functionality. And this kind of small specific model, cheap, and I guess easy to run, even in your own local environment. This is because who needs, there is no code base, there is no application, there is nothing that can ultimately be a ultimate painkiller to everything, to every problem in the world, to every possibility and every functionality and every demand. and this also true in the AI. So there should be no the more intelligence the model has, the more overall knowledge the model has, the better routing through the pieces. But I think for doing specific things, they won't be done by they will be only routed by the bigger models, and they will be done by small, this kind of effective nano code, whatever abbreviation, models, which will have the possibility their development to be targeted at a certain direction and a certain job, specific job, very specific job. Let's see what these guys did.
And here's the part that I love. These improvements in instruction following reliability and long context comprehension also make the GPT-4.1 models considerably more effective at powering agents. And so, of course, there are two things that come to mind with that. Anything where you're building agentic systems like with Crew AI, or what I've been doing more recently, vibe coding. That is essentially taking a coding model like this and wrapping it in agentic behavior through Windsurf, through...
Yeah, for example, Meta is going into the direction with experts. And I think OpenAI is going to the other direction of making more specialized and small models. I think that would be the one. And Google Gemini 2.5 experimental, which is an astonishing model for coding. I haven't even tried it for other tasks. They're still going for the ultimate painkiller, like the 2.5 is. I think it's tech in general painkiller.
Cursor.
And that's why they don't even compare it now to OpenAI, because they don't really have a ground for comparison anymore.
Through Replit, and it is very exciting to see this field emerge. Now, here's something interesting which I didn't really understand. 4.1 will only be available via the API. In ChatGPT, many of the improvements in instruction following, coding, and intelligence have been gradually incorporated into the latest version of 4.0, and we will continue to incorporate more.
Yes, because generally, as I said, the intention for this model is not to be used for general knowledge. And the guy which is sitting in front of the browser and start typing a prompt, he's the ultimate general knowledge requester. He's requesting general knowledge. The demand in the browser is general knowledge. And the demand in the API is a specific and consistent behavior.
Or with future releases. So they really are naming things in the most complex way and just making it difficult for themselves, but whatever. Now here's the crazy part. We will begin deprecating GPT 4.5 preview in the API, as 4.1 offers improved or similar performance on many key capabilities at a much lower cost and latency. 4.5 preview will be turned off in 3 months on July 14th, 2025 to allow time for developers to transition. Now, that is, in my opinion, really bad. Imagine you're a developer and you get 4.5, what, a month ago, 6 weeks ago, and then you are already notified.
It's not so big deal, because there was not so much reason to move to 4.5. For example, there is a reason. If Google now decides to say no more Gemini 2.5 Pro, that would be a significant. But what was the reason for one moving to 4.5? Not so much. It was not the best in class, I think. So much. It was not so much better.
You're going to have to
when it was introduced, that's what I mean.
Migrate off of it. That is a huge pain in the butt. But they go on to remind us, GPT 4.5 was introduced as a research preview to explore and experiment with a large compute-intensive model, and we've learned a lot from developer feedback. Now, again, I don't really think 4.5 is going away. It is a massive model. It'll probably be used to distill smaller models, and it probably was used to distill 4.1. And so as they learn how to get more out of 4.5, I suspect we will see it again in the future. So let's look at some specific benchmarks. Here is SWE-bench verified accuracy, GPT 4.1 beating O3 mini high. That is crazy. That is a full thinking model, GPT-03 mini high, using the maximum amount of thinking and getting beat by a non-thinking model. And it's much faster, and it's much cheaper. And look down here, GPT 4.1 mini as compared to 4.0 mini, a substantial improvement, 9% on SWE-bench verified, compared to 24%. That is a multiple time improvement. And just for those of you who may have forgotten, SWE-bench verified is a benchmark in which the model is given a GitHub repo, a description of a problem, and must generate a patch for the code. So this is the most real world coding benchmark there really is. And they also focused on code diffs. And so what that means is the model will not just rewrite an entire file, but it's actually really good at rewriting only certain portions. So basically editing smaller portions of it, which of course saves time and saves money, because instead of having to output the entire file again, which the other models tended to do more often, it will just edit the specific lines of code that need editing and leave everything else the same, aka the diff. So here's the Aider Polyglot benchmark, 4.1, whole and diff.
That's interesting.
GPT 4.0, whole and diff, O1 high, whole and diff. And so you can see across the board, there is a specific accuracy reduction when doing a diff instead of the whole file. However, with GPT 4.1, there's actually a slight improvement. It's basically the same, but a 1% improvement on creating a diff versus creating a whole file. And they also point out that GPT 4.1 is actually much better at front-end coding. And so rather than me talking about it, let me just show you the demo from the live stream.
But there's also kind of the intangibles of when you're using a model. You know, when you're creating a front end, is it functional? Is it beautiful? Does it nail the mark? And so for that, we have a little example of a flashcard app I've been making.
You're learning Hindi.
Yeah, working on it. And so I've got a prompt here. It's pretty complicated. I'm asking for this app pretty specifically. I want a nice 3D animation when you click on the flashcard. And so when I give this prompt to GPT 4.0, this is what I get. It follows some of the instructions, and some of the app is functional. But we really trained GPT 4.1 to do better. And that model, you can see it looks way better. It's discovered colors. It can also do the 3D animation. So we think you're really going to like this improvement to front-end coding.
Now, obviously, they still have a lot of work to do in terms of beautification of the front end, but I think this is a big improvement. All right, so during the live stream, they brought out the CEO of Windsurf to talk about the improvement of 4.1. They've had it for a little while, and so here it is. GPT 4.1 scores 60% higher than GPT 4.0 on Windsurf's internal coding benchmark, which correlates strongly with how often code changes are accepted on the first review. Their users noted that it was 30% more efficient in tool calling and about 50% less likely to repeat unnecessary edits or read code in overly narrow incremental steps. This means faster iteration and smoother workflows. That is great. We also have Kodo. They tested 4.1 head-to-head against other leading models, and what they found across 200 meaningful real-world pull requests with the same prompts and conditions, 4.1 produced the better suggestion in 55% of cases. Notably, 4.1 excels at both precision, knowing when not to make suggestions, and comprehensiveness, providing thorough analysis when warranted, while maintaining focus on truly critical issues. And Varun specifically mentioned that 4.1 is much less verbose than other models. He said other models tend to get very blabby when they're giving you their output in vibe coding scenarios, but 4.1 doesn't do that. That is very nice to hear. And they also gave a demo of instruction following during the
I think verboseness, if you need a specific thing, the consistency what the model can provide you, that's the interesting part. It's not the capability of being or not verbose. For example, it's very interesting. What would be the if you if you tell in your prompt that you don't need verboseness, what is the percentage of the responses that will not have the verboseness by your criteria, of course. And if we are close to 100, if you are 100, yeah, guys, we are there. But if we are not 100, and we are close to 100, and we have an improvement towards 100% from the previous model, I think that's the most significant improvement following instructions, because the knowledge, it's teachable. But if the companies and the closed source, open source, whatever researchers at the moment find a way, the model to behave in a consistent and expectable way, that's the simple moment everybody calls in a different with a different abbreviation, and everybody is afraid of that moment.
Live stream, and this is incredibly important. Let me just play that video for you now.
So just like coding, we have made the model way better at instruction following. It now strictly follows all the instructions that you provided. So using all the feedback that we received, we created this internal instruction following eval, where it mimics all
internal instruction following eval. That sounds very interesting. Let's hear it. I think in Gemini, Google are not saying, but they have also this. In Gemini 2.5 Pro, the way it digs into the topic, I think they have quite the same concept there.
API developer uses our model. So each sample in the eval contains a complex set of instructions, where each instruction.
But admirations to these guys, because they are speaking the strategy, they are speaking the change.
Belongs to one of several categories, like formatting, ranking, ordered instructions, overconfidence, and so on. And collectively, that sample is given a difficulty rating from like easy, medium, and hard. And we see that this model does really well across all those axes and on difficulty levels as well. So here you can see the hard subset eval results, and this model is so much better than the previous 4.0 model.
So what's an example of like a really hard set of instructions to follow?
Yeah, so let's say you're building a trip planning application, and you give it instructions like make sure you receive all the info from the user before answering them. And when you answer with the trip itinerary, make sure.
But this is evaluation. This is a test. I was thinking they're speaking of algorithm.
Sure, it's in a table.
I think I misunderstood. Yeah, we need an algorithm as well for internal instruction following.
Table format. It contains 5 rows, 3 columns. The columns are formatted in a certain way.
Yeah, I don't know about you all. I remember all the times that you learn these tricks in prompting where you're like, no, you really need to make this a table, not a list. Trust me, my boss is going to be super mad at me if you don't get this right. Yeah, so hopefully no more of that.
Yeah, and people actually were doing that just so that they could get the model to follow an instruction. None of that is needed now. The model follows all your instructions to the T, and it does really well.
Okay, and now look at the benchmark. This is internal OpenAI instructions following eval accuracy hard subset. We have 4.1 at 49% as compared to 4.0 at 29%. And 49% is comparable, although trailing by a bit, of 0.1, 0.3 mini, and 4.5. And we can see 4.1 mini is actually substantially better than 4.1 nano and even 4.0 mini. And for multi-turn instructions, we also got a substantial improvement. Check this out. We have GPT 4.1 here, which is a substantial improvement over 4.0.
But now I don't understand. What is this now? GPT 4.1 nano is scoring half of the percentage of GPT 4.1 mini. Multi-turn conversation to properly use 4 types of information from previous messages. Okay, let's see the other one. Instruction following. 4.1 nano is 32% versus 4.1 mini, which is 45%. That's a hell of a 10% difference. Let's see what's the price difference after that. I think this is not relevant. Multi-challenge. The idea is not to multi-challenge the smallest model. I don't think that's the idea.
This out. We have
So why they present this comparison? For multi-challenge accuracy, you need to compare the multi-challenge targeted models. I don't think the 4.1 nano is
GPT-4.1 here, which is a substantial improvement over 4.0, but it obviously does trail behind the thinking models. Now, here is needle in a haystack. If you're gonna have a massive context window, a million token context window, being able to actually utilize that context window effectively is just as important as having it to begin with. And what do we see here? We have a perfect score. Successful retrieval up to 1 million tokens and 100% successful retrieval. And so they actually did a really cool demo during the live stream in which they placed a single line of non-log code into a massive log file and find the line that's different from the others. They didn't even specify what the line was. Let me show you that demo now.
To test the log file that I'm about to upload, that file is NASA's server request response log file from 1995 August. So in this log file, you can see the client name in the left that made the request to NASA's servers. You see the timestamp, the resource that was accessed, and the HTTP response code. This is a long file that contains a lot of log lines. And you can see on the left that this is about 450,000 tokens of content here.
Nice. So you just couldn't use this with our past models?
Yeah, this wasn't possible. Now what I've done is I've snuck in a line that is not actually an HTTP request response. Let's see if it can find it.
Okay, so it's a little needle in a haystack, except in this case, you don't even tell it what the needle looks like. It's just figure out what's different and tell me.
Exactly, so it's gonna sift through the whole file, do some pattern matching to see how all the log lines look like, and then try to see if there's one that does not look like the others. Okay, there is a line that it has spit out that does not look like an HTTP request line to me.
It does not.
Okay. Let's see if this line is indeed in the log file that we uploaded. I'm going to copy this keyword.
Nice.
Yeah.
There it is.
Great. So it was able to find this line that has been snuck in into this deep 450,000 token log file that is like very hard to find. So it did pretty well.
All right, so let me show you just a couple more benchmarks. We have MMMU accuracy, which is answering questions on models, charts.
okay, but that was very interesting. How much time it took? Did we? I don't think we saw that.
It's multimodal, certainly. So check this out. 4.1 beats 4.0 by about 6%. It's still trailing 0.1 high, and it's about equal with 4.5. But of course, much less expensive. And we have 4.1 mini right here, just dominating 4.1 nano and 4.0 mini. We have Math Vista. Here it is again, 4.1, beating 4.0, matching 0.1 and 4.5. That is the theme we're seeing. It's basically much more efficient than the thinking models in 4.5, but with similar quality. So they were really able to do a lot with this model. Here's a Charkive reasoning accuracy, 4.1, same thing, on par with 0.1 and 4.5. All right, so let's talk about pricing. Here is GPT.
Yes, let's talk about pricing. I think that's the most interesting piece of information in this announcement.
4.1, $2 input per million tokens.
Two.
Cash input, 50 cents, and output, $8 for a blended total price of $1.84 per million. Now, 4.1 mini, 40 cents for input, 10 cents for cashed input, $1.60 for output, blended total, 42 cents. I really think 4.1 mini is going to be their true winner of the announcements today. And we have 4.1 nano, 10 cents input, 2.5 cents cashed input, and 40 cents for output for a blended total of 12 cents. These are extremely cheap models. So that's it. There's a bunch more benchmarks.
10 cents input. 10 cents input. Can we go back? $0.40 output for the 4.1 nano, but I don't think somebody will require so much output from this model. It's more of an input. What would be the hot price? The 10 cents for the input, I guess.
Of 12 cents. These are extremely cheap models. So that's it. There's a bunch more benchmarks that they have in the blog post. I'll drop the link to that in the description below. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.
Yes. Astonishing video. Like and subscribe this guy's video. And guys, see you in the next one.